Static motor analyzers test the insulation system of an electric motor. The motor insulation system is responsible for up to 50% of electric motor failures, even more on higher voltage motors. Let's take a quick look at the motor insulation system. Insulation strength degrades over time due to heat, electrical stress, mechanical stress, abrasion, and contamination. The most common insulation failure is between turns of wire that are next to each other in the same coil. This is called a turn-to-turn fault. Other wire-to-wire insulation faults are phase-to-phase and coil-to-coil. When the insulation fails and there is a path to the core, it is called a ground wall insulation failure, since the stator core is at electrical ground. Oftentimes, when a motor overheats or has a turn-to-turn failure, the excessive heat will cause a ground wall insulation failure also. The most common insulation fault is a turn-to-turn insulation failure. A surge test is the only test that can find turn-to-turn insulation weakness and failures. Let's look at how a surge test works. Insulation is tested by putting a voltage across the insulator and measuring the current flow. To get a voltage across a turn or loop of wire requires high voltage and high current. This often happens when a motor is line started. The surge test simulates a motor start, but with much less energy. In concept, to run a surge test, charge a small battery or capacitor up to several thousand volts. Then connect it to the motor winding through a switch. When the switch is closed, a large amount of current flows into the winding, causing a voltage to appear across the wire insulation. This voltage is due primarily to the inductance of the winding. The battery quickly discharges and the whole surge test is done in a few microseconds. If the winding insulation is weak, a small discharge will occur, which causes the voltage waveform of the winding to change. Static analyzers detect and report this change. The ground wall insulation is the insulation between the stator windings and the stator core. When the motor is new, this ground wall insulation is tested at voltages up to 5 times the operating voltage. For motors in the field, ground wall testing is usually done at 2 times operating voltage plus 1000 volts. A Megger test or Meg-ohm test typically tests the ground wall insulation at or below the motor operating voltage. This has limited value as insulation breaks down non-linearly as the voltage increases. A high-pot test is a DC ground wall insulation test but run at a higher voltage. This covers the peak voltages a motor would normally see with some level of margin. To detect the non-linearity of weak ground wall insulation, a higher than operating voltage is applied, but the voltage is applied as a steady ramp or in steps up to the final test voltage. SKF static testers plot the voltage applied and the resulting current flow. Where the ground wall insulation is weak, the current will rise much more quickly than the voltage. This is the most complete test of ground wall insulation. Both the IEEE and IEC committees have published standards for testing of motor insulation. EMCM testers comply with these testing standards. SKF offers 2 families of static motor analyzers. The AWA is a fully automated Windows-based analyzer with complete insulation testing capabilities. Since it is automated, you can be assured that the testing is consistent and the results are repeatable, regardless of who is doing the testing. The AWA has 3 switch test leads, so all 3 phases of the motor can be tested without reconnecting the leads. A color touchscreen interface and familiar Windows operating system make this tester easy to use. A keyboard is available as well. The AWA can also connect to a network LAN, USB printer, power pack, foot switch, and safety lights. It also includes a resistance test for winding construction tests. The AWA is available in 2 package sizes, with 2 kV and 4 kV analyzers in the small package, and 6 kV, 12 kV, and 12 kV high output in the large package. These automated analyzers are ideal for predictive maintenance and quality control. The DX family of static motor testers are small, light, manually operated testers. ideal for motor repair and rebuilders, and for predictive maintenance customers on a budget. The DX family has models with maximum test voltages of 4 kV, 6 kV, 12 kV, and 15 kV. High output models are available for both the 6 kV and 12 kV models. The DX uses a color touchscreen interface, usable in direct sunlight and with gloves on. It has 3 switched high-voltage test leads, a voltage adjust knob, a push-to-test button, USB for printer and data export, foot switch, and safety light. There is no keyboard option, so all actions are taken on the touchscreen. Let's take a quick look at the DX static tester user interface. The lowest row of icons shows the test type or file location and settings. These are arranged for a left-to-right flow of all the test steps. The top row of icons shows the configuration of the test selected in the bottom row. The large upper area of the display shows test results. To run a test, select the test type desired. Select the lead if applicable. Press the PPT button and ramp the test voltage. For the long DC ground wall insulation tests, a PTT lock is available. Save test data by pressing the Save File icon. Data can be exported via USB for archive and desktop report generation. Reports can also print directly from the DX. Companies' logos can be added to the report. For testing of very large motors or form-wound coils, the voltage range of static motor analyzers can be extended using a power pack. These solutions boost the output voltage to 24 kV, 30 kV, or 40 kV for the ground wall insulation DC tests and the turn-to-turn insulation surge test. DC motors armatures can also be tested using Baker's ZTX adapter with a static motor analyzer. The ZTX lowers the surge voltage while increasing the current. This allows bar-to-bar testing of the armature with excellent fault location. Static motor analyzers provide complete non-destructive testing of the motor insulation system and winding construction in accordance with IEEE and IEC industry standards. This key information gives you early warning of insulation weakness, avoiding unplanned downtime.
For more information about Megger Baker Instruments electric motor test equipment, go to megger.com/Baker.